Hi everyone, I'm here to present SkySync Swarm, a unified drone swarm simulation and control platform built to tackle one of the biggest challenges in modern drone system. Our solution, SkySync Swarm, is a one-stop unified framework that merges four capabilities into a single system: drone simulation engine, swarm coordination, AI-powered adaptation, and autonomous mission planning. On the screen, you can see my prototype in action. Let me now walk you through the project workflow, starting from how the drones are initialized, tasks are allocated, paths are planned, and finally how waypoints are verified and visualized. But before that, let me give you a brief intro to all the document files that I'll be using to demonstrate my prototype. Server.py, a Flask based communication server. Client.py, a simple simulated drone client. Controller.py, an orchestrator that assigns tasks and computes paths. RRT.py, a Python RRT planner. Task allocator.py, an APF.py for cooperative modules, whereas check waypoints.py and plot waypoints.py are the helper scripts to validate results. Let me now take you to each file one by one. First, server.py. Server.py. It is a central REST hub for telemetry and mission commands. It uses Flask and exposes update state and get waypoints and status. Second, client.py. It is a simple, here it is. It is a simple simulated drone client used in demos. Starts at random position XY and fixed altitude Z, that is 5.0. If a waypoint is returned, move a fixed step zero point 0.5 meter towards the first waypoint and then send updated telemetry on the next iteration. Simulates battery drain randomly. Provides a realistic feedback loop for the orchestration, and multiple you can run multiple clients with different IDs to evaluate a real swarm. The third file is called the heart of the system, that is controller.py. Here it is. This is the main orchestrator that assigns task and computes path. It converts the 2D path to 3D waypoints by preserving drone altitude and applying APF smooth to refine the path. It allocates tasks based on a greedy system, which is primarily based on priority and proximity. Orchestrator tick is the single function that glues allocation, planning, and smoothing. That is why, for me, it is called the heart of the system. RRT.py. It generates a collision free path between start and goal in a bounded sampling region. Here it is. It is a fast and straightforward planner for producing demonstrable waypoint sequences using RRT or OMPL. RRT star.m is a canonical RRT reference implementation included for research and reproducibility. Let me give a quick look to this RRT.m, which is written in MATLAB. That is the language that I've used. Task allocator.py is a greedy, it uses greedy for task allocation, greedy method. It is a simple deterministic and great for demo scenarios. It is optimal and constrained for scheduling the paths. Second file that I'm going to is apf.py. apf.py is an artificial potential field smoothing for an existing waypoint list. It treats the last waypoint as the goal. Obstacles are repulsive charges, iteratively computes a gradient force, and applies a small step to waypoint positions, producing a smooth path that slightly pushes waypoints away from the obstacles. APF is convenient, computationally cheaper layer to make piecewise paths smoother and more collision resilient. It is not a formal guarantee against local minima. Last but not the least are the check waypoints and plot waypoints.py. Let me give you a quick look to those files as well and then quickly start with the demonstration. Here it is plot waypoints.py and check waypoints.py to verify the results. Fine. Now let's start with the demonstration. As to show you guys, I'm already running the server here, and my one of and I'm already running the client.py here with my first drone 1, and I'll be again running it with Python Unified Swarm. Okay, I could have. Okay, drone 2. This is the main server. It is my first drone 1 gateway points. And this is the status. If I'll refresh it, it is giving me the status for drone 2. Previously, it was giving me the for the status drone 1. And if I'll show you the status for drone 2 as well. This is for the drone 2. I check weapons. Okay. This is check weapons. From here, I can check the status of my final waypoints and verify it. And I would also, um, last but not the least, I'm plotting the waypoints. Waypoints. This is the plotted graph. Let's go back to the code. So the orchestrator assigned a task near 40 and 10, one of the configured tasks in controller.py. RRT planner produced a interpolating path from the drone's current XY to the goal XY. The final waypoint equals to the task XY. The Z value 0.50 appears because the prototype orchestrator tick preserves the drone's starting altitude when converting the 2D RT path to, to the 3D waypoints. APF smoothing adjusted intermediate points slightly, which helps avoid obstacles if any were present. This output shows the entire pipeline worked, telemetry present in drone state, orchestrator tick, computed assignments, RRT returned a path, APF smooth it, and server returned the waypoints. Now wrapping up and telling you the use cases of my project Sky Sing Swarm. For defense and surveillance, it is a multi-drone patrols for adaptive formations. It is for disaster response, research and rescue in dynamic conditions, agricultural coordinated crop monitoring and spraying, research and education, a plug and play platform for swarm robotic studies. Now you will ask me what makes SkySync Swarm different? Why? What makes it unique? I just want to tell you it's not just a simulator or a planner, it's a complete ecosystem, a unified framework, everything from simulation to AI in one. Scalability supports swarms from 2 to 100 plus drones. Hacker modular design allows integration with real world drones. SkySync Swarm demonstrates how autonomous drone swarms can be simulated, trained, and deployed in a single platform. By solving the problem of fragmentation, we bring industries and researchers close to realizing the full potential of swarm robotics. From defense to disaster relief, SkySync Swarm is the future of intelligent aerial coordination. Thank you. That's all. And I would like to end my prototype here.